Data 8, homework number 1, solutions. First, let me say that some of you had a bit of trouble editing the homework. I'm sorry about that. Let me give you some tips. If you're on a Mac, you should edit it with Apple's Preview program, which is built into your Mac, and it's the default PDF editor. But don't just save your changes. When you're finished with your homework, go to File, Export as PDF. It's already a PDF, but by exporting it in this way, you'll save all of the changes and the words will wrap nicely so that we can read it in Gradescope. If you're not using a Mac, I found this nice website called PDF Escape. PDFescape.com seems to do quite a nice job. You can take the homework, drop it in here, and start filling out your answers. And when you're done, you can just download the resulting document. So let's try that out. I'm John. My collaborator here is myself, and I'll start answering the questions, starting with problem 1. Problem 1 gives us this quote. Since 1970, the percentage of people age 18 to 34 in the United States who live at home with their family increased 48%, from 12.5 million to 18.6 million. It's not actually the percentage that went from 12.5 million to 16.8 million. It's the number of people. So the correct answer here is to say that the number of people aged 18 to 34 increased from 12.5 million to 18.6 million since 1970 to 2006. The next question asks you, what are the causal factors contributing to this increase? How come there are so many more people living at home with their family? One change in the United States that we've talked about quite a bit in the class is that the population of the country is growing. Could that be one explanation of why the number of people living at home has increased so much? Let's take a look. Here's the US population. In 2006, it was 300 million people. Back in 1970, it was 205 million people. So if we look at the total percent increase to go from 205 million to 300 million, that is a 46% increase in the US population, which is an awfully good explanation for the 48% increase in the population that's living alone. So it's not at all that a greater fraction of the total people is living at home. Instead, there are just more people in the country. In order to receive full credit for this question, we should have said that the population increase is a reasonable explanation. And if you wanted to cite some additional statistics, you might say that it went from 205 million to 300 million, which is an increase of 46% from 1970 to 2006. Now, we did give partial credit for other answers, like pointing out that it might be because the economic pressures are forcing more and more people to live at home. And it's true that those effects may be taking place. But the fact that this statement never even mentioned the population growth was quite misleading, because that's a reasonable explanation of this increase from 12 to 18 million people. Problem 2 is about a Berkeley study. A Berkeley study where they gave money to poor families, but required as a condition for payment that the families participate in a range of programs to improve their health and education. So here we have a combined treatment of money given as well as attendance to these range of programs about improving their health and education. And we focus on the initial study where 505 communities were selected to have similar poverty levels. So they're similar in this one dimension to begin with, but who knows how different they are in other dimensions. Here, the managers randomly chose 320 to receive progressive benefits. That's what's called a randomized controlled study. And we would expect that by randomly choosing 320 out of the 505, that there wouldn't be any systematic differences between the ones that were chosen and the ones that weren't chosen, because they were selected randomly. The Berkeley researchers focused on the impacts on health, and they measured health outcomes for all 505 communities, both the ones that received progressive benefits and the ones that didn't. And they had substantially lower average rates of illness for the ones that received benefits. Okay, so did this analysis have a treatment group and a control group? Indeed, they did. So the 320 communities selected to receive progressive benefits are the treatment group. The other 185 communities are the control. And so the answer is yes. This analysis did have a treatment and a control group. It was a randomized, controlled experiment, because those who received the treatment were controlled by the experimenter, and the experimenter chose who received the treatment by randomly selecting them from one population. Does the study provide evidence that being in a community receiving progressive benefits is associated with a lower rate of childhood illness? For an association, we need a difference between treatment and control, as well as a comparison of the outcomes. And that's exactly what we have. The outcomes were compared, and it turned out that there were substantially lower rates of illness in the treatment group. Yes. Does the study provide evidence that being in a community receiving progressive benefits causes a lower rate of childhood illness? The answer is yes here as well, because this is a randomized controlled experiment. So we would expect, based on the fact that we selected the treatment group randomly, that it's unlikely there are any systematic differences between the treatment and control groups aside from the treatment itself. And so, since changing only the treatment leads to a change in outcome, that's evidence of a causal relationship. Now, it's not proof, and in statistical studies like these, what you get is not proof, but instead evidence that it is unlikely to see that difference in outcomes unless there were a causal relationship behind it. Now, could you imagine a world in which we saw this outcome even though we conducted this randomized controlled experiment? Yes, it's possible. So that's why we don't say the study proves that there's a causal relationship. Instead, we say the study provides evidence. Finally, this says most families eligible for Progressa participated in the required health programs, but 3% did not. Suppose we only limited our study to the 320 eligible communities. And within those, we compared the health outcomes of the families that participated with those that did not. Would this analysis constitute an observational study, a randomized controlled experiment, or neither? This is an observational study. In this setting, some researchers offered a benefit to both the treatment and the control. But it was up to the families who participated to decide whether to take that treatment or not. So, in this case, the experimenters cannot control who selects to have the progressive benefits and who doesn't. And that means it's not a randomized controlled study anymore. In fact, there may be a systematic difference between those who chose and those who did not choose to take these benefits. So while we may be able to observe an association between those who took the benefits and their health outcomes, it will be much harder to say anything about a causal relationship between that treatment and that outcome. Problem 3, how the other half lives. The Reverend Whitehead was skeptical of John Snow's conclusion about the Broad Street pump. He investigated the drinking habits of those who had survived. Why was it important to study this group? Whitehead was completing the method of comparison that John Snow had started. A comparison looks at those who have a treatment and those who don't, and then the difference in their outcomes. Snow originally only considered one of the outcomes, those who had died, didn't consider the other outcome, those who had survived, and ended up finding that there were a lot of people with one treatment condition, drinking from the Broad Street pump, that died. So many that it seemed like compelling evidence to him to investigate further. But a complete comparison would look at those who drank from other sources and whether they survived or not, in order to make the comparative claim that if you drank from the pump, you were more likely to die than if you didn't drink from the Broad Street pump. So we accept many answers here in this open-ended question, but one reasonable thing to say is that establishing association between drinking from the pump and death requires comparing those who did and did not drink from the pump, and those who did and did not die. If, for instance, many had drunk from the pump but survived, Snow's argument for a strong association would be weakened. Problem 4. Myopia or nearsightedness results from a number of genetic environmental factors. There was a study wherein parents of children aged 2 to 16 were seen as outpatients in a university pediatric ophthalmology clinic, and they were given a questionnaire about light exposure. And it asks, was this study observational, or was it a controlled experiment? What are we studying here anyway? Well, we're studying whether there's an association or causal relationship between the child's light exposure and whether they have myopia. In this case, there was no randomized split between treatment and control. Instead, a questionnaire was offered to everybody, but it was up to those families how much light exposure was given to a child, not up to the experimenters. So that's an observational study. The study found that the children who slept with a room light on before the age of 2, 55% were myopic. Of the children who slept with a night light on before the age of 2, 34% were myopic. And of the children who slept in the dark before the age of 2, only 10% were myopic. The prevalence of myopia during childhood was strongly associated with ambient light exposure during sleep at night. Do the data support this statement? This statement says it's strongly associated, meaning if there's a difference in treatment, the amount of light exposure, then it appears there's a difference in outcome. And here we see quite a big difference in outcome. 55% and 34% and 10% are not numbers that are very close together. So don't be shy when you see very different numbers for very different outcomes with very different treatments. That's when you say, yes, there is a strong association. Now you might wonder, is 55% really different from 10%? Or could that have just been random variation? And we will answer that question. And the answer will be that even with only a handful of observations, that would be a very big difference. And now they were asking this questionnaire of everybody who left the clinic between January and June, which is presumably several hundred people. So certainly 55% and 10% on a study of that scale are quite different, and therefore there's a strong association. CNN reported the results of the study. Night light may lead to nearsightedness. What does it mean to lead to something? That implies causality. And this was an observational study. Observational studies don't provide evidence of causality. They just provide evidence of association. The final paragraph of the CNN report says that several eye specialists had pointed out that the study should have accounted for heredity. Myopia is passed down from parents to children. In what way do you think this fact might have affected the data? So what data are we talking about? We're talking about this association that we've discovered between room lights and myopia rates. And the question is, how would heredity have affected these, such that such an association would appear? Well, it could be that myopic parents like to leave the lights on because they can't see. So that would be an explanation of why the lights were on, and an explanation of why the children were myopic through heredity that had nothing to do with a causal link. So for this question, we accepted really any explanation that linked heredity to both changes in light exposure, and changes in the myopia of the children, such as saying something like, myopic parents might prefer to have the lights on at night and might tend to have myopic children through heredity. After all, before the age of 2, it's not the children's choice about whether the lights are on. It's up to the parents. Problem 5. After executing x equals 10, Yulin tries as many expressions as you can to evaluate to 99. So the problem with the first one is that you can't say 10x. You have to say 10 times x minus 1. Likewise, you can't say xx. You have to say x times x minus 1. By the way, if you're ever unsure, you can open up data8.berkeley.edu and create a new Python 3 notebook, where you can test out things like multiplying x times x and subtracting 1 after you set x equal to 10. What about 11x minus x plus 1? So 11x is 110, and what you'd like to subtract is 11, which is x plus 1 with a set of parentheses. What about the absolute value of x times x, so that's 100, minus the absolute value of 9 minus x? 9 minus x is negative 1. The absolute value of that is 1. If I subtract 1 from 100, I get 99. If I want to take the absolute value of negative 99, I do require parentheses in Python. And if I want to use the built-in pow function, then I need a comma between its arguments. So this raises x to the power of 2 and then subtracts 1. Pow x2 minus 1 is 99. Okay, problem number 6. Suppose we want to compute d from x0, y0, x1, and y1 using the Pythagorean equation. Well, all we need to do is translate this expression into Python. So we have x0 minus x1, and we want to square that. And we also have y0 minus y1, and we want to square that as well. Now, in order to take a square root, we need to surround this whole thing in parentheses in order to raise it to the 1/2 power, or the 0.5 power. Problem number 7. Suppose that Johnny, another Data 8 student, is tasked with writing code to find the middle of 3 distinct values. There is this clever idea, which is that if you want 3 values, and you're not interested in the largest or the smallest, but the one in the middle, you could add all 3 together and then subtract out the smallest and subtract out the largest, which is almost what's written here, except it's not correct because we haven't subtracted out the smallest. Instead, we've added it because the min is added. Parentheses fix the problem. We can say a plus b plus c minus parentheses max a, b, c plus min a, b, c. And that's one correct answer. Another correct answer is to distribute this minus over the min and the max and write it like that. Okay, below is a plot from Lecture 1 that compares the number of characters to the number of periods in each chapter of Little Women. How many periods are in the chapter with the most characters per period? Well, we have to figure out what a character per period is. And for each dot, we can compute that by dividing the number of characters, in this case it's about 12,000, by the number of periods. In this case it's about 60. And 12,000 divided by 60 is about 200 characters per period. Is that a lot? Is that a little? Well, let's look at another dot. So here's another dot that looks like it has a lot of characters. It has 24,000 characters and 160 periods. Now, 160 periods at a rate of 200 characters per period would be way up here at 32,000. But that's not where it is. It's at 24,000, or about 150 characters per period. And what about way out here? Well, this has 400 periods and about 40,000 characters, So that's something like 100 characters per period. Okay, but we're looking for the one with the most characters per period. Well, it turns out it's this one. This one had 200. Now, how might we convince ourselves that that's true? Every dot that has 200 characters per period will fall on a line. Which line is that? Well, it goes through this dot, and it also goes through the point 0, 0. Now, the point 0, 0 is not actually on this chart, because we see the characters dimension goes from 45,000 down to 5,000. 0 would be evenly spaced. The same distance between 5,000 and 10,000 would be between 0 and 5,000. So 0, 0 lies right down about here. And if we draw a line through this point, going up 200 characters per period, it's a line that kind of goes way up here, way up to 40,200. Now, nothing except for this dot is anywhere close to that line. So this one is clearly the one with the most characters per period. And how many periods does it have? Well, something like 60, because it's about a fifth of the way from 50 to 100. And how about how many periods are in the chapter with the most characters? Well, here we only have to look at the vertical dimension. It's this dot with the most characters, and it has about 390 periods in it. So that's a quick walkthrough of homework 1. I hope you enjoyed it. To turn in your homework, you would download it. And as you can see in the downloaded version, all of the answers are there. So that's something that you could turn into Gradescope and get full credit.